Multiply and divide fractions. Multiply with reducing. So let's consider 4/9 times 6/5. If we multiplied this out just as it's written, we would get 24 over 45. Now if we look at this, 24 and 45 have some common factors. They both can be divided by 3, so we can think of this as being, this is 3 times 8, this is 3 times 15, have a common factor of 3, and we would get 8/15. Or we could think of this as 24 is divisible by 3, and that would leave us with 8, and 45 is divisible by 3, leaving us with 15. Another way of doing the same problem. But if we factor each of those, so we could have written this as 2 times 2, that was our 4, times our 6, which would be 2 times 3. 9 would be 3 times 3, and then there's our 5. And then if we just took off our common factors and then multiplied everything out, we would get the 8/15 without having to go to the 24 and 45ths. So what we're looking at is here that we can take out those common factors before we multiply. So when we multiply, we can remove a common factor from the numerator and denominator. This actually makes it much easier to do our multiplication because our numbers don't get big. Let's take a look at our examples. So in example 1, we have 6/35 times 14/15. So we could write it out as prime factorization. In fact, if that's easier for you, go ahead and do that. So you could write this out as 2 times 3 times 2 times 7, and 5 times 7 times 3 times 5. Okay, this gets kind of long, so what I tend to do is I start looking for common factors in my problem in the first place. So if I have 6/35 times 14 over 15, I happen to notice that 14 and 35 have a common factor of 7. So if I divide this by 7, I get 2. And if I divide 35 by 7, I get 5. And then 6 and 15 have a common factor of 3. So 6 divided by 3 leaves me 2. And 15 divided by 3 would leave me 5. Now I can multiply that out, and I'm going to get 2 times 2, which would be 4, and 5 times 5, which would be 25. Now if I go back up to the one where I had it in a prime factored form, and I started crossing off ones that are like, notice that I still end up with 4/25. So 2 ways to get to the same answer. You don't really want to be multiplying 35 times 15. The numbers get big, and it's really hard to reduce when they get bigger. So let's take a look at example 2. Here I have 6/14 and 35/13. So again, I could write this out in a prime factored form. So I would have 2 times 3 and 5 times 7 and 2 times 7, and it would just be 13. We won't bother writing 1. Or again, look for those common factors. One of the first things that I noticed here is that 6 and 14 have a common factor of 2. So 6 divided by 2 would leave me 3. 14 divided by 2 would leave me 7. And then 7 and 35 have a common factor of 7. So 7 divided by 7 would be 1, and 35 divided by 7 would be 5. I can just multiply what I have left over. I have 3 times 5, which would be 15, and 1 times 13, which would be 13. Again, I could go back up to my prime factorization and just cross off those things that are like, and I'm going to get 15/13. So 2 different ways of doing the same problem.